Okay, 122. Very similar to what we did last Wednesday when we did 121. We're going to learn about discriminants. So if you missed that, you're going to be able to get it right here. Go ahead and circle discriminants. Kind of another word that's going to pop up. It deals with quadratic stuff, but what does the discriminant mean?
Everything under the square root. Minus 4ac.
Close.
Under the square root.
It's under the root. It's the stuff under the square root. So let's write the quadratic formula. Look at the stuff under the root.
Or b
Did you say x squared minus 4ac, right? Yeah, so it's b squared minus 4ac. So again, let's write the quadratic formula. We got x equals negative b plus or minus square root of b squared minus 4ac all over 2a. Now the discriminant was just that little part of it. Remember that it's the stuff under the root, not the root. So the root's not included. It's just b squared minus 4ac. So that's our discriminant. Okay, some problems. These first two problems are going to be really easy. Some problems are going to give you a quadratic, and they're actually in standard form. They're going to go x squared x number, and they're just going to ask for the discriminant. Wow, that cable's in the middle of this thing. Okay. Yeah, no clue how that happened.
Power went out.
Okay, find the discriminant. Now, since it's the notes, let's write out what we're doing. Find the discriminant. So, b squared minus 4ac. Go ahead and write b squared minus 4ac. B squared minus 4ac. So, my a is 1, my a is 4, my b is 1, my c is negative 3. So, my discriminant is 1 squared minus 4ac, which is 4 times 4 times 3. B squared minus 4ac. So 1 squared minus 4 times 3. And I'm getting, what am I doing? Oh, the negative 3 right here. Right there. 4 times 4 times negative 3. And you should get positive 49. Ignore the first thing I put in there. All right, 1 squared minus 4 times negative 3 is positive 49. So that's it. That's your discriminant. So that's what some of the questions are going to ask. What's the discriminant? Just do b squared minus 4ac, and it's 49. The second example, there's a reason I put the second one up here, because of the answers that you should automatically know aren't going to be them. First, remember, the discriminant does not include that square root. It's that part in the quadratic formula just under the root. So it's just b squared minus 4ac. So don't expect to have any kind of square root be part of your answer. So that eliminates what? That's your A and C. There's no way in the world that it's this or this, because there's no roots at all. So we're just b squared minus 4ac. So on this one, what is my b? Negative 4. Now if you're going to square a negative 4, how do you got to do it for your calculator? You got to put it in a parenthesis. If you're going to square a positive number, just go ahead and do it. But if you square a negative number in your calculator, there's b squared minus 4, 2, 5. 4ac. So I want negative 4 squared, but hug it in a parenthesis, minus 4, 2, 5. And this is going to be my discriminant, negative 24. No roots. This doesn't go under a root. The discriminant is just b squared minus 4ac. Part of the song, part of the quadratic formula. Negative 24. All right, so that's just part of the questions you might get on Objective 122. Now, the harder part is really going to be when you see this phrase. So what we're going to need to do is remember what they're asking. Determine the nature of the roots. All right. The phrase, determine the nature of the roots. So we're going to talk about what it means, and then understand half of the questions on this objective will start out by saying, determine the nature of the roots. And then they'll give you the quadratic equation. Here's what it means. Determine the nature of the roots basically means the same thing as, what does the discriminant tell us about the solutions?
Well, if it's positive, I have 2 solutions.
To the quadratic formula. Yeah, and that's what we talked about last time. If the discriminant is positive, expect 2 real solutions.
If it's negative, then it'll have no solutions.
2 real solutions. Remember that the discriminant, everything we've done up until like recently, we always get 2 answers out of our quadratic formula. That's because the discriminant has always been positive until recently. If it's negative, we will have no real solutions, but we're going to put something else here too. No real solutions. And then in parentheses, we're going to have no real solutions, but what's actually going to happen is you're going to actually have 2 imaginary solutions. So if you don't have real solutions to a quadratic, you have imaginary ones. So put 2.
The ones with the eye?
The ones with the eye, yeah.
Kind of.
You can say 2 complex ones or 2 imaginary ones. If it has an eye, it's got an imaginary part to it. So
I
2
just said put 2 eye.
2 eye solutions or something. 2 imaginary ones. 2 imaginary solutions. Keep that in mind. Those are the same thing. If you got no real solutions, it's because you have 2 imaginary ones. Now, if the discriminant comes out 0, that means that you got negative b plus or minus 0, the square root of 0 is 0, over 2a. So when you go plus or minus 0, basically, if it's 0, it kills all of this. So all you have is one solution, negative b over 2a. So if the discriminant is 0, you're going to have 1 real solution. 1 real solution. So what's happening when they say determine the nature of the roots? They're not saying find the answer. They're just saying how many answers would you get? And the discriminant will tell you. If it's positive, you're getting 2. If it comes out negative, you aren't getting any real solutions. And if the discriminant comes out 0, you'll actually just get 1. So let's look at these 3 examples where one of them is going to be 0, one of them is going to be 1, one of them is going to be none. All right, here's my first one. Determine the nature of the roots. There's that phrase. Determine the nature of the roots. 3x squared plus 36x plus 108 equals 0. What we want to do to determine the nature of the roots, as they said, is do the discriminant. B squared minus 4ac. What's my b?
36.
So 36 squared minus 4 times what? Times
3
what?
times 108.
Times 108. So go ahead and tell me what we're getting there.
That's 0.
Comes out to be 0. So this one, the discriminant, came out to be 0. Since the discriminant is, go ahead and circle 0 and cross these out. Since the discriminant is 0, we should expect how many real solutions? 1. If the discriminant is 0, expect 1 real solution. Now they might not write it 1 real solution. It's in here somewhere else. 2 distinct real ones? Nope. No real ones? Nope. Cannot be determined? No, I determined it. A unique real solution. Unique is 1 or different, so it's 1 unique solution. That's it. All right, let's look at the next one. Determine the nature of the roots. That basically means, what's the discriminant going to tell us? 1, 2, none. Let's go b squared minus 4ac and find it. 2 squared minus 4, 2, 3, or negative 3.
It'll come out to 28.
We're at 28.
Yeah.
Okay.
Positive.
All right, it comes out to 28, and again, the more important thing is not the 28, it's that it's positive 28. So b squared minus 4ac gave us a discriminant of positive 28. Since that discriminant is positive, what are we going to expect?
2 distinct real solutions.
Yeah, 2 real solutions, and they're going to say 2 distinct real solutions. So 2 real solutions. Their wording, as in an EOI or any kind of test that you take, their wording might be a little different, but 2 distinct real solutions, that's it. Distinct means 2 different or 2 unique real solutions. And this last one, now let's do it. I'm promising you it's going to come out negative because it's the only one left.
Negative 87.
Yeah. 3 squared minus 4, 4, 6 came out to negative 87. And I've kind of already filled in for you so you can tell this is going to be, since the discriminant is negative, we should expect no real solutions. However, your brain's got to remember if there's no real solutions, however, we have no real solutions, we can expect to actually have 2 imaginary ones. So if you don't see an answer choice that says no real solutions, don't panic. No real solutions means 2 imaginary.
Where's that? Oh.
imaginary solutions. Yeah, they're going to say two unequal imaginary roots. And remember that you can sometimes interchange complex and imaginary. Imaginary is really talking about there's an I part to it. Complex is just kind of another way of saying a number that has an I part. All right, so we got two unequal imaginary roots. Now, one other way with our graphing calculator. To do this exact same thing, but without the discriminant, we're going to talk a little bit about what roots might mean. And this is kind of foreshadowing some stuff we're going to see really soon. So, here's another way to solve example 2, example 3, 4, and 5 without doing the discriminant and with using our graphing calculator. Think of these quadratic equations that you had in 3, 4, and 5. If we think of them instead of as their equations, where they're like 3x squared plus 36x plus 108, if we actually made them quadratic functions, where instead of having equals 0 on the right, I change it to y equals, and then I put all the quadratic business there. The reason that that's going to help us is that's going to make it from being just a simple quadratic equation to being a function, which is y equals, which is something I can graph, because I have a button on the calculator that says y equals. So what we want to do is we're going to go back and we're going to graph them. But we need to understand what roots mean. What a root to a graph is. You know like what roots are on plants, right? Yeah. You have a plant and then you have the ground, and then the stuff under the ground you can't see, that's called the root. Well, think of a root kind of in a similar way. A root is where your graph hits the x-axis. Like the x-axis is that flat line. So what we want to say is, like, is it going to hit the x-axis once, which would be one root? Does it come through and go back and make two roots, or does it not cross through the x-axis at all, which would make it have no roots? So let's go back to the first one. So back to the top. Now, we have an answer to this. What was it? Like how many real solutions or fake solutions or imaginary solutions? We only had one, right? Now let's graph this. Instead of equals 0, put this in as y1 on your graphing calculator. And let's graph y equals 3x squared plus 36x plus 108. 3x squared plus 36x plus 108. Now, since you have one real solution or one root, I would expect this to hit the x-axis once. And we graph it. And that's what it looks like. All quadratics are going to make this U shape, which is called a parabola. But if we only have one root, it's because the U comes down, and then the vertex or the bottom of it hits the x-axis and it goes back up. That's what it looks like to have one root. Now let's look at the next one. How many roots did this next one have? 2. So let's go ahead and put it in. And what you should expect is that this one is going to hit that x-axis twice because you had 2 roots. So go 2x squared plus 2x minus 3. So instead of having that equal 0, put it in as a function, y equals. This one had 2 real roots. So when we graph it, looks like that. And here's our roots. There's one of them, and there's another one. And on a future objective, you might actually be asked to tell me what the roots are, and you can see that there's one right here at 1, and there's one right here at -2. But you can see them. You can visually see them. I can see if it hits the x-axis once. I can see if it hits the x-axis twice. The last one says no real roots. So the answer we got for this was that this had no real roots. So go ahead and put this in your graphing calculator. Let's look at what it looks like when you have no real roots. Or actually what we put is that you have 2 imaginary roots. So 4x squared plus 3x plus 6. What do you expect to see out of this? If you have no real roots, what do you expect to see? It's not hitting the x-axis. Whatever it does, it won't hit the x-axis. And that's what you see right there. You have your parabola up here, but if it doesn't hit the x-axis, it doesn't have any roots. So if you wanted to do this a different way, what you could do is graph each of them, and when they say determine the nature of the roots, graph them all as functions, and tell me, does it hit the x-axis once? Does it hit the x-axis twice? Or, in this case, it doesn't hit the x-axis at all, which means 2 things. Does it have any real roots? No. And if you have no real roots, what do you actually have? Two imaginary ones. So that's one way to look at graphing these things to tell the nature of the roots. And just in summary, what does it mean to be a root on a graph?
Where it touches the x-axis.
Where it touches the x-axis. So if you're ever asked a question of what are the roots or how many roots does it have, you can graph it and you can either see where the roots are, or if they just want to know how many they have, you just say how many times did it hit the x-axis. Once, twice, or none. And more complicated functions might actually hit it 3 or 4 times.